Let's get started with final exam review. As I said a little bit before I started recording, we're just going to go through a few questions to kind of jog your memory about the previous chapters that we've gone over. So we're going to cover chapters 1 through 8. There are about 11 questions here in this presentation that we'll go over. You can ask any questions that you have, and then we'll be done. So it's been a pleasure. I'll say that on the front end. And I'm here for you. So without any further ado, we'll do like we did last week, where I just kind of went through the problems. If you want to jump ahead and try to answer them, that's fine. You do you. After we finish with this class, I'll post a practice final exam where you'll get about 10 or 15 questions. I can't remember how many I put up, but it'll be about 10 to 15 questions to kind of help you think about the other chapters that we've covered so far. And on Monday, you have your final, and we'll talk about that at the end. So here we go. You notice that there is more traffic between 8 and 9 a.m. You have to figure out if this is an example of an experiment, observation, conclusion, or theory, or a hypothesis. So we covered this like the very first day. You have to remember the different definitions. And the key word here to help you assign which one it is it's something that you notice. Something that you notice is an observation. Question 2. Which of the following measurements has 3 significant figures? I'll go through and figure out how many significant figures we have in all of these, just to help jog your memory of some of the rules. So in A, we've only got 2 significant figures. The other 2 zeros are placeholders. In B, again, we've got 2 placeholder zeros and 1 significant figure here. So I'll write the placeholder zeros in. 2 placeholder zeros. And here we have 1 placeholder zero. In C, there are 3 significant figures. We've got a decimal point, and then the first digit after the decimal point is a non-zero. So that means everything from this point on is significant. So that's 3 significant figures, and that's what we're looking for. But we'll continue doing the others. This one, we've got 2 significant figures and 1 placeholder zero. That's here. That's the placeholder zero. And then in E, we have 2 significant figures and 1 placeholder zero. So don't let those placeholders confuse you. The answer here is C. Now pause for a little bit. And if you have any questions, or if you're like, hey, can you do more about significant figures? This would be the time. So you can throw your hand up to give yourself time to type out your question. You can state your question, or you can just wait for like 10 seconds, and I'll just keep going on to question 3. Okay. We're going to move on to question 3. A dose of aspirin of 5 milligrams per kilogram of body weight has been prescribed to reduce the fever of an infant weighing 8.5 pounds. The number of milligrams of aspirin that should be administered is. Well, let's highlight the relevant information here. We have 5 milligrams per kilogram of body weight, and we have an infant that weighs 8.5 pounds, and we need to figure out the number of milligrams of aspirin to give to this little baby. Now, it's true. You can't just, number one, you're not giving an infant a pill. You're doing the liquid stuff in a syringe and putting it in their mouth and hoping that they take it. Hopefully, if you have children, you never have to give them aspirin because of a fever. But if you do, this is a very real problem. So you look at the back, or you call your pediatrician and ask how much you should give them. And it is based on their body weight. So if they're younger than 6 months, they just got a deal in most cases. And that fever will just have to subside unless it's dangerous. So this is like an actual thing, not just made up. So 5 milligrams per kilogram of body weight. When you write it out, that looks like a conversion factor, because it is. So what we have to do is go from a weight in pounds to weight in kilograms, and then use our conversion factor to get to milligrams of aspirin. What's not given in this problem, which will be provided for you in all the information that you get to go along with the final, is the equality that tells you how many pounds are in 1 kilogram. That's our equality. You don't need to memorize that. It'll be provided for you. What you will need to do is know how to write the conversion factors and choose the right conversion factor to solve the problem. So starting with our weight in pounds, we first have to go from pounds to kilograms, which means we've got to use one of these conversion factors that talks about kilograms and pounds. We're going to use this first one here because we want to cancel out pounds, which means since pounds are in the numerator currently, we need to also put pounds in the denominator. The next one that we have to use is our conversion factor. We're going to have 5 milligrams of aspirin for every 1 kilogram of body weight. Make sure that your units check out. We get to kilograms. Then we get to milligrams of aspirin. In your calculator, you do 8.5 divided by 2.2 times 5. Your calculator is going to tell you 19.318 and some other stuff. We need 2 sig figs here, so that's 19 milligrams. And the answer is B. Now pause here for a minute. This problem goes back to chapter 2 when we were doing equalities and conversion factors. We did percentages. So that was a math heavy chapter. If conversions are not your thing. And we did metric conversions, so metric to metric, English to metric, that kind of thing. If that was a struggle for you, you definitely want to focus on that chapter. Try to do a little practice. Okay. If there's no questions, then I'm going to move forward. Okay. Question number 4. A cheeseburger from a fast food restaurant contains 19 grams of fat, 20 grams of carbohydrate, and 28 grams of protein. That's a big burger. 28 grams of protein, that's a lot of burger. How many kcals of energy does the cheeseburger contain? And in the problem, it tells you that the caloric values for food are as follows. 9 kcal per gram for fat, and 4 kcal per gram for carbohydrates and for proteins. You have to round off the answer for each food type to the tens place, and then you have to add it up. So here's how we set this one up. Each of these caloric values for the foods, that's a conversion factor. So we're going to take 19 grams of fat and multiply that by the conversion factor of 9 kilocalories for every 1 gram of fat. And we're going to do that for each of the categories. So next is carbohydrates. Carbohydrates is a long word, so I'm going to just write carbs. Oops. Finally, we have to deal with that 28 grams of protein. That is also 4 kcals per gram. So we're going to do each of these individually and round to the tens place and then add it up. "19 times 9 gives you 171. When you round that to the tens place, it's 170 kcal. 20 times 4 is 80 kcal. And then 28 times 4 gives you 112 kcal. But we've got to round that to the tens place. It's 110 kcal. Then we add them all up. You get 360. There's our answer. With these questions, it will usually tell you to round your answer off to the tens place. So don't ignore that part. And just to show you the units. So you're canceling grams, and you're ending up with kcals for each one of these. Remember that calories are energy. You could also have joules. I'll pause here for a second. And if there's any questions, you can let me know. Otherwise, in about 10 seconds, I'm going to move on. Let's go on to question 5. How many calories are required to raise the temperature of a 35-gram sample of iron from 25 degrees Celsius to 35 degrees Celsius? And iron has a specific heat of 0.108 calories per gram degree Celsius. So we'll talk about this a little bit. The question is asking about how many calories. So this is a heat problem. And the heat is equal to the specific heat multiplied by the change in temperature multiplied by the mass of the sample. Specific heat, this tells you how much energy you need to raise the temperature of 1 gram of sample by 1 degree Celsius. So if you had 1 gram of iron and you wanted to raise that temperature by 1 degree Celsius, you would need 0.108 calories to do so. That's what the specific heat tells us. So now we can fill in the numbers. Application sharing. It's been weird today. Okay. And we are back. I was just about to start the other way too. Like, alright, this is taking too long. But if it happens again, we're just going to switch over to the PowerPoint. You'll still get a video. It'll just take me a little bit longer to put it together. But you'll also still get the notes and everything, so it won't affect anything. It'll just take me a little bit longer to put it together. So we're talking about specific heat and how to calculate the heat of a reaction. So we take the specific heat, we multiply by the change in temperature. We're starting at 25 degrees Celsius, and we're heating up the sample to 35 degrees Celsius. So 35 minus 25 gives us 10 degrees Celsius. And the mass was given in the problem as 35 grams. Degrees Celsius will cancel, so will the grams, and you're left with calories. So in your calculator, you just literally multiply 0.108 times 10 times 35. Your calculator will tell you something around 37.8. We need two significant figures here. So the answer is B. Now, in that same chapter, we also talked about the heat of vaporization and heat of fusion. I'd recommend going over those things too. That was in chapter 3. I'll pause here for a second, make sure everybody's all caught up, and then we can move on to the next question. Question 6 is from chapter 4. We were talking about atoms, what they're made of, the protons, neutrons, and electrons. We also talked about electron configurations. So I would definitely recommend reviewing those things. And you can use your homework. You can go back through and kind of look through those problems and redo some things. There's also the dynamic study modules, which are extra credit on mastering chemistry. And we'll talk about that at the end of class. Which of the following gives the correct numbers of protons, neutrons, and electrons respectively in a neutral atom of 10? So let's talk about what these numbers mean. So of course we've got the element symbol, the top number is the mass number, the bottom number is the atomic number. The mass number is equal to the total number of protons plus the number of neutrons. And we can use that to solve for the number of neutrons. The atomic number is simply equal to the number of protons. The number of protons is equal to the number of electrons in a neutral atom. So that's a quick little refresher for you to talk about protons, neutrons, and electrons. We need to figure out the number of protons, neutrons, and electrons in this neutral atom of 10. The atomic number we're given, and that's 50. If the number of protons and electrons are the same in a neutral atom, then we also know the number of electrons. We can actually rule out some of these answers. So A, we can rule out because the protons are wrong. C we can rule out because that's wrong. We can also rule out D. So we just narrowed down to 2 answers and we haven't even finished yet. So if you're in a place where you're like, I know some of these are wrong, get rid of them. Scratch them out. Rule them out in your mind. And narrow it down. Focus on the answers that you're like, okay, it's got to be one of these 2 or one of these 3. That will always help you on an exam. Now, to figure out the number of neutrons, we have to use the mass number. The mass number is 118. And if we subtract the number of protons, which is 50, then we should get the number of neutrons. So I'll write that out for you. Mass number minus the number of protons will give you the number of neutrons. And that's 68. So there was a lot in this chapter, mainly concepts, but you'll definitely want to go over chapter 4. It's one of the more abstract chapters that we covered, and usually folks have a little bit of problem wrapping their minds around some of those concepts. So do yourself a favor and revisit it. I'll wait a few seconds before I move forward. Number 9. Which of the following correctly gives the correct coefficients for the reaction below? This is from chapter 7, balancing equations. Let's see what we're starting with. We've got nitrogen, hydrogen, and oxygen. On the reactant side, we've got 2 nitrogens, and hydrogen is in 2 places. It's in both compounds. So that's 4 plus 2 equals 6 hydrogens total, and then 2 oxygens. On the product side, we've got 2 nitrogens, we've got 2 hydrogens, and 1 oxygen. Clearly, we need to balance some things. The hydrogen is in 2 places. It's in the hydrogen peroxide, and it's in this nitrogen compound. Since the nitrogen is already balanced, if we're going to try to balance the hydrogens, we should add coefficients in front of the peroxide and try to leave the nitrogen alone if we can help it. We've got 6 already. We need to try to balance these 2 out. But we also have to take into account the fact that every time we add 1 here, we're adding more oxygen as well. So normally you would go for the lowest common denominator, But in this question, what I would recommend is going through the options that you're given. You can rule out some of the options, and here's why. It can't be D because D doesn't have the smallest whole number ratios. Two, 4, 2, and 8, you can reduce those down. Same thing for E. 2, 4, 2, 4, you can reduce that down. So that's not a final answer. So it's got to be A, B, or C. Now we just said that going through here and checking to see if it's balanced, it's not. So that means that it can't be C. Now you're down to either A or B. And you can try these coefficients out and see which one gets you the right answer, which will have the correct, you'll have the same number of each atom on both sides. When you do that, you'll find that it's A. So I'm going to kind of let you do the work for that one. But we narrowed it down to A or B simply by, doing a little bit of work and using a little bit of common sense, mental math a little bit, but using the concepts that you know. That will really help you take less time on the exam, and it'll help you make sure that you don't, waver and say, oh, but maybe it could be this, but maybe it could be that. Immediately get rid of the answers that you know for sure are wrong. Trust yourself. The nuclear reaction shown below is an example of what type of process. This was chapter 5, where we talked about nuclear chemistry. There's all these different particles that you need to recognize, and you need to remember how to do the different decay methods like alpha decay, beta decay. Remember what fission and fusion are. So there's a lot of terminology there. And there's some things to remember. Not really math heavy, though. To figure out what type of process is being shown, you need to recognize the particles. This is a particle that you should recognize. It is an alpha particle. And when an alpha particle is released, it is called alpha decay. Which one of the following compounds contains an ion with a 3+ charge? This is from chapter 6, where we covered ionic compounds and molecular compounds. We did naming, we did ions, we did all kinds of things, polarity, Vesper theory, so the shapes of different molecules. We did Lewis structures, so that was a pretty big chapter. You'll definitely want to revisit that one. Just kind of look over the rules for naming and do some practice. Use your homework, use that Mastering Chemistry. Go through that and use it to help remind yourself of some of these different topics and do some practice. We need to figure out which one of these contains an ion with a +3 charge? +3 charge, remember a positive ion is called a cation. Cations are usually metals. Because metals lose their electrons to form ions. Each of these compounds here are ionic compounds. Ionic compounds are made of ions. Go figure, right? So we need to look at the cation, which is the positive one, that's the metal, and the anion, and figure out the charges. In A, we've got 3Cl, that's chlorine, right? So it's the chloride ion. There's 3 of them. Chlorine is in group 7A, which means that its charge is going to be the group number 7 minus 8, which gives you -1. If I have 3 chlorine ions, or chloride ions, excuse me, then I've got -3 as my charge here. I've only got 1 iron ion. That means that the charge of this ion has to be equal but opposite of this -3. When I add these charges together, I should get 0. Just so happens that the first one is the right answer. But I'll go through and do one more of these just to break it down again. We'll do E. Starting with the oxygen, that is the oxide ion. It's in group 6A. The charge for that is going to be the group number 6 minus 8, which is -2. And I've got 1 of them. So that means that -2 is my charge for my anion. That's the negative ion. I've got 2 sodium ions. So 2 times the charge of the sodium ion should equal 2. That means it's got to be +1. The other way that you can figure that out is, since sodium is one of the representative elements, you can look at the group number. It's in group 1A, and the charge is equal to the group number. And that's for representative metals only. So I just wanted to give you another example of how you can break down an ionic compound and figure out the charge for the cation and the anion. Now pause here, and if you have any questions, you can let me know. But I'd also like to check in with you and let me know how you're doing. Is this helpful to kind of jog your memory and say, oh yeah, I should probably study that? So let me know. Is this session helpful for you? Is there anything else that I can do to help get you ready for the exam? Talk to me. Is this helpful? I hope it is, because we're spending the whole time doing it. So let me know if there's something else you need. Okay. So we've only got a few more questions, and then we'll be done. Question 10. Had to put up some kind of a stoichiometry question for you. Which I realize. Yeah. We've got a reaction here. It's already balanced. How many grams of water are needed to produce 150 grams of magnesium hydroxide? This is also from Chapter 7, and it's a stoichiometry problem. Where we're given the mass of one compound, and we need to figure out how many grams of another compound are needed, or how much we're going to produce, that kind of thing. This is the question. We've got 150 grams of magnesium hydroxide. How much water do we have to make that? Here's our plan. We start with the number of grams of magnesium hydroxide. We have to get to moles. To do that, you need the molar mass of magnesium hydroxide. I'll write that out up here. To figure this out, you need your periodic table. You need to look up each of the elements and figure out what the mass is for each element. So magnesium, if you look that up, it's 24.31 grams. Plus we've got oxygen and hydrogen, and there's 2 hydroxides here. So that means 2 times oxygen and 2 times hydrogen. That gives you a total of 58.33 grams in 1 mole of magnesium hydroxide. Back to our plan. Now that we've got moles of magnesium hydroxide, we need to get to moles of water. That's where our mole factor comes in. We're going to use that to get from moles of magnesium hydroxide to moles of water, and it comes from the chemical equation, the balanced chemical equation. Last step, we go from moles of water to grams of water. We'll need the molar mass of water to do this. You look up hydrogen, and there's 2 of them. You look up oxygen, there's only 1. 18.02 grams, and 1 mole of water. Now we can put our numbers in. The number of grams that we're starting with comes from the problem. Then we write a conversion factor using the molar mass. Then we write a mole-mole factor. This is from the balanced chemical equation. We want to convert from magnesium hydroxide to water, which means the number of moles of magnesium hydroxide in the chemical equation will go on the bottom. Now you can see that it'll cancel out to give us moles of water, which is going on the top. The last piece here is to use the molar mass of water. The grams are going to go in the top this time because that's what we want, and we're going to cancel out the moles. Always do unit analysis and make sure that you get to the units that you're looking for at each step. To cancel out units, you need the same unit in the top and bottom, or the numerator and denominator, in order to cancel. But you're only canceling the units, not the numbers. That's what you'd put in your calculator. And when you do that, your calculator answer will be something like 92.678, a bunch of other numbers. Okay? We're going to round that to 93 grams. That's letter D. I'll pause here. If there's any questions on this, you can let me know, or you can raise your hand. Otherwise, I'll keep going in a few seconds. I'll give you about 10 seconds to take it all in. Last problem. This is from Chapter 8. Where we did all the gas laws. There's definitely math here, but the math wasn't too bad. Make sure that you review those gas laws. You'll need to recognize the variables and how to use them. Not going to make you memorize them, but you should definitely know how to use them. A 5-liter tank contains helium gas at 1.50 atmospheres. What is the pressure of the gas in millimeters of mercury? So as usual, You go through, you highlight the numbers, and then what you're asked for. You identify these things. This is a volume. This is a pressure. But what's the question asking? What is the pressure of the gas in millimeters of mercury? That's a conversion question. So this volume, we don't care about it. Ignore it. We don't need it to solve this problem. All we need to know is how atmospheres and millimeters of mercury are related. So make sure that when you're going through these problems, you pay attention to what the question is. Sometimes you get additional information that you do not need. You do not have to use every single number in every single question. Sometimes the information is there to make sure you're paying attention. Our units cancel, and we're left with millimeters of mercury, which is what we want. And I should label this is an equality. You do not need to memorize these different equalities for the units of pressure. That will be provided. You're just multiplying 1.5 times 760, and that gives you 1140. Which is letter A. Notice that if you said, oh, I must multiply 5 times 1.5, that answer is there, okay? This is misleading. So make sure that you read the problem and you know what you have to do. That's the trickiest part about the gas law questions. Taking in all the information you're given and figuring out which gas law answers the question, not which gas law has all of these variables, because you may not need to use them all. I'll pause here for a few seconds. That's it for today. So remember that your chapters 9 and 11 for Mastering Chemistry are due on Sunday. I gave you as much time as I could. And then there's extra credit assignments. You don't have to do these, but they're available for you to work on. There's the dynamic study modules, and then there's some other ones that are just kind of general chemistry, skill building. It's extra credit. It won't hurt you. It'll only help. So if you've missed some assignments in Mastering Chemistry, it's not a bad idea to try to make up some of those assignments by doing a little extra credit. It'll also help you study for the exam, because I've got topics that hit some of the major things like the stoichiometry and some of the other tougher topics that we do. Your final exam is on Monday, May 3rd, and you have to take it on Monday. So it'll be open all day, but you've got to take it on Monday. It's approximately 70 questions, and it's just going to be questions that cover all of the chapters from the entire semester. So if you have any questions, now's a good time. Otherwise, you're free to go.